Hi, I'm Eva Murphy from Electronic Engineering at IT Sligo, and this is my Leaving Cert Maths Grinds channel. I'll regularly add new videos for both higher and ordinary level maths, so make sure you subscribe below and click the bell icon to be notified of new videos. Okay, so 2018 question 2, the first sequence and series question of that paper, there was a few of them. The first three terms of a geometric series are x squared, 5x minus 8 and x plus 8, where x is an element of R. Use the common ratio to show that x cubed minus 17x squared plus 80x minus 64 is equal to 0. Okay, I can't remember what page sequence and series is on. Circle. Here. Okay, there's two types of sequence and series on your course. There is an arithmetic sequence, or arithmetic, however you pronounce it, and a geometric sequence. Okay, in an arithmetic sequence, you are either adding or subtracting the same value from all of the terms in the sequence. In a geometric sequence, you're multiplying or dividing by an amount to go from one value to the other. Okay, so that's the two big differences. There's two formulas on both, and then a third one on geometric. The first formula you use if you need to find a formula to give you a specific term in the sequence. So in other words, when I develop a formula for Tn, that allows me then find any term in the sequence. So in other words, I could find the 100th term by letting n equal to 100. So to find any of these formulas, well, we'll do the arithmetic one first. You need two pieces of information. You need A, which is the first term, and you need D, which is the common difference. And if you're coming up with the formula, you just let n be n in that one. Okay, and then in a geometric one, again, you need the first term, and then you need OR, which is what they call the common ratio when it's a multiply or divide one. And then Sn is the sum of. So if you get a question about if you add up the first 20 terms, for example, what's your answer? Then that's an S20. So it's the sum of the first number of terms. Okay, and you may be asked to develop a formula for the sum of the first n terms, and in that case you leave n as n, and again you use the first term and the common difference, or if it's geometric you'll use the first term and the common ratio. And then there's a sum to infinity one that gets asked quite a bit on the geometric sequence. That's if you have an infinite number of terms, what would it sum to? Okay, so sum to infinity, that's the infinity symbol like that if you can't read it. So sum to infinity. So anytime you see that word infinity, it tends to be this one. Okay, and that formula only works, you'll only ever have a sum to infinity when your common ratio is less than 1. Okay, so that is the bulk of your course. A couple of other things, little hints, when you have multiple terms, not so much for this question, but it's good practice. So I'm going to write down the three terms here. It's x squared, it's 5x minus 8, and it's x plus 8. It's good practice to call the one in the middle Tn. Then this one is one up from it, and then this one is one below it. Okay, of course I could call this Tn plus 1, Tn plus 2, because they're all relative. Okay, n just stands for a particular term, and of course this is one below it and this is one above it. Why is it good practice to do it this way though? In some questions you are giving terms. I'm just making up a question here now, 3a, b and 10, and you're asked to solve it for a, b, and it works very well when we have our terms labeled one below, one above, and so on and so forth. So I'll try and root out one of those to just show off, I suppose, that point that I'm making there, or why when it's useful to label it like this. Okay, so a geometric sequence, if it is a geometric sequence, then you can state that this term divided by this term would be the same as this term divided by this term. Okay, so you can say that Tn plus 1 over Tn is equal to Tn over Tn minus 1. Okay, that's what a common ratio means. So in other words, if I made up a sequence and I'm going to multiply my sequence by 3, so I'd have 2, 6, 18, 18 by 3, 54. Okay, what I'm saying to you in this maths language here is that 54 over 18. Okay, so that could be my Tn plus 1, Tn, Tn minus 1, and then this would have to be Tn minus 2. So 54 over 18 should be equal to 18 over 6, which should be equal to 6 over 2. Okay, that they're all linked as such, and of course I should get 3. So that's what it's meant by the common ratio. Okay, and you can see in all of them, I get 3 is equal to 3 is equal to 3. And that's how you prove a sequence is geometric. Okay, that formula there. So that's the first real piece of theory that you've got to know. Okay, so what does that mean for this question? Well, it says use the common ratio. So this is the common ratio, the bit I have in a red box. So I'm going to say that x plus 8 over 5x minus 8 is equal to 5x minus 8 over x squared. Okay, and then I'm going to cross multiply as such, so that I get x squared by x plus 8 is equal to 5x minus 8 by 5x minus 8. Okay, or x cubed plus 8x squared is equal to 25x squared minus 40x minus 40x plus 8 8s are 64. Let's bring everything over to the left. Minus 25x squared, that's going to be minus 80x, and I'll bring it over and it'll be plus 80x minus 64, of course equal to 0 now. X cubed 8 minus 25 is minus 17x squared, plus my 80x minus my 64 equals 0. Yeah, and that's it. Okay, but this is the critical piece of theory you've got to know for a geometric sequence. Okay, and that's equal to, I suppose I should have said it was equal to, or what we call the common ratio. Okay, so that's the first bit. If f of x is equal to x cubed minus 17x squared plus 80x minus 64, show that f of 1 is equal to 0 and find another value of x for which f of x is equal to 0. Okay, so we have to show that f of 1 is 0 first. So if I have to find f of 1, you can see that I'm replacing x with 1. So therefore you replace all of the x's with 1. Okay, so you're literally comparing those two there. So that is 1 cubed minus 17 times 1 squared plus 80 times 1 minus 64. And if I bang that into a calculator, I should get 0 if it's a solution. Plus 80 minus 64. Okay, therefore f of 1 is equal to 0. Okay. Find another value of x, okay? Well, if x is equal to 1 is a solution, then x minus 1 is a factor. Okay, and that comes from quadratics. I'm going to long divide in here now. I'm just showing you where I've got that from. If I factorize this, okay, you can see x is equal to 2, x is equal to 1 is the solutions or the roots. Okay, so they can be called roots or solutions. Then to go back one line, you literally bring the 2 over and you get the factor. Okay, so that's what I'm doing here. X is equal to 1 is a solution, and therefore I go back one line to form the factor, because it's always the factor that you long divide in. Okay, so I have x cubed minus 17x squared plus 80x minus 64, and I long divide in x minus 1. Okay, so how do I do this? Well, I'm looking at x and I go, what do I multiply it by to bring it up to x squared? Okay, so I need another, or sorry, bring it up to x cubed, I multiply it by x squared. And then you multiply that x squared by everything on the outside. So x squared by x is x cubed. X squared by that minus 1 on the outside is minus 1x squared. Change the sign, put a line under, and you should always get a term to cancel. So in this workings out, I should get the x cubes to cancel. In the next part, it should be the x squareds and so on. So I've minus 17x squared plus 1x squared. So that's minus 16x squared plus 80x. I take this down because I haven't used it yet, minus 64. Okay, and then you repeat the process. It's like you ignore this bit in the middle and you're just doing it again. What must I multiply that x by to bring it up to minus 16x squared? Because remember, now I want to make these cancel. Okay, so I definitely need a minus. I need the 16. I have 1x there, so I just need one more x to bring it up to x squared. Okay, and then you multiply that by everything on the outside. Okay, so that you get minus 16x by x is minus 16x squared. Minus 16x by minus 1, well, minus by minus is a plus. 16 by 1 is 16. Okay, change the sign, and they cancel. So then you have 80 minus 16, that's 70, 64x. Take down this one, minus 64. And then you do it all over again. Okay, get a different color again. Let's go purple. What must I multiply by that x to bring it up to 64x? So it's a plus 64 in this case. 64 by x, 64x, 64 by minus 1, minus 64. Change the sign, and you're good. Okay, so what I have found is that my other two roots, okay, because this is an x cubed, it has three roots or three solutions, okay? One of them we know is x is equal to 1, and the other two are contained within this quadratic up here. Okay, so just to finish it off, I'm going to just erase this bit over here. It's in the recording anyway. Okay, so let's finish it off. So my other two solutions are in the quadratic here. So let's solve it. X and x, the factors of 64, that gives me 16, 8 eighths. They'll have to be minuses. So I'm getting equal roots. X is equal to 8. Okay, which is why it says find another value. Okay, because it had equal roots. Okay, if I was to draw that quadratic, just to quickly give you a feel for it, what it would look like, I am having one solution at 1. I'm having two more way out here at 8. Sorry, it's nowhere drawn to scale, okay? And it would look something like, I could go either way. Let me do it a different way. So it's going to turn out there. Okay, so it's where that part of it just sits there at 8, okay? And that's what equal roots would look like when the curve sits on top of 8, okay? And then that's the one where it cuts through it. Okay, of course it could be a mirror image of that, but something like that, that's what I'm getting. So x is equal to 8 is the answer to that part B. Okay, part C. In the case of one of the values of x from part B, the terms in part A will generate a geometric series with a finite sum to infinity. Find this value of x and hence find the sum to infinity, okay? Well, this is this formula here, and you'll see it quite a bit as you do exam questions, where the sum to infinity is equal to a over 1 minus r, where a is your first term and r is what's called your common ratio. Okay, so what's it saying? In the case of one of the values of x from part B, okay, so I have 1 and 8 as my x values, okay. The terms in part A will generate a geometric series with a sum to infinity. So I had x squared, I had 5x minus 8, and I had x plus 8. Okay, so now we know that x is equal to 1 and x is equal to 8. Let's see what we get for these. So 1 squared, 5 times 1 minus 8, 1 plus 8. So I am getting 1 comma minus 3 comma 9. Okay. My common difference is always Tn plus 1 over Tn, okay, or Tn over Tn minus 1, it doesn't matter. So 9 over minus 3, and you can see I'm getting a common ratio there of minus 3. Okay, so that won't sum to infinity. Remember that your common ratio must be less than 1 for it to sum to infinity. Okay, so no sum to infinity. Okay, let's try my other one, which was x is equal to 8. Let's see how I get on. So in this one, I'm going to get 8 squared. I'm going to get 5 times 8 minus 8, and then 8 plus 8. So 8 eighths are 64, 5 eighths are 40, minus 8 is 32, 8 and 8 is 16. Okay, that looks okay. So it's still equal to Tn plus 1 over Tn. So let's go 16 over 32. So I'm getting a half for that one. So that one is going to sum to infinity. Okay, so my formula is to infinity. I've now found the value of x. So the value of x is 8. So I now need to find the sum to infinity. So it's equal to a over 1 minus r. My first term is 64. I got that from here, over 1 minus my common ratio, which is a half. So that's 64 over a half, which is equal to 128.
If you've enjoyed this video, then why not join us in IT Sligo and use maths in practice. In conjunction with industry, we've designed an exciting new program in electronics and self-driving technologies, which uses cutting-edge techniques such as artificial intelligence, computer vision, and virtual and augmented reality. You'll need a H5 in maths to qualify. Check out the link below.